Okay, in this lesson we're going to learn, we're going over the learning standard of add, subtract, multiply monomials and polynomials, and we're going to focus on how we multiply monomials today. So our vocabulary is monomial, polynomial, and coefficients. We've gone over the definition of all of these before, so they're not going to be explicitly defined in the lesson, but you can review your notes from previous lessons to figure out what those are, and we'll use them in context so you'll be able to understand what I mean. Okay, so our first example is this one right here. And first of all, let's recall a monomial is the product of a number and variables. So there's no addition or subtraction or division in it, unless the division is in terms of a fraction with a number in the denominator. So the first one here is a monomial, and this right here is a monomial. So this is the product of monomials. So we're going to focus on how we can multiply these two things together. This is a fairly simple answer, and a lot of you might be able to see how to do this already. Since this is all multiplication, right, there's multiplication in between all parts of this monomial and all parts of this one, and there's multiplication between the two monomials. We can actually just rearrange all these terms. And the way that I want to, rearrange all the parts of the term, because each monomial is in of itself one term. That's what makes it a monomial. So we can just rearrange it. First of all, we can drop the parentheses. We don't need those when we're not distributing. When you can't drop the situation where you can't drop the parentheses is something like this, where you'd have to distribute the 3 in. But we don't have that here, so we can just drop them right here. 4 times a to the third, b to the fourth. Now, since it's all being multiplied, we can use the nice property of commutativity. Multiplication is commutative, so I can rearrange all parts of the terms. I'd like to put the coefficients together, and I'd also like to put the variables with the same base together. Okay, that's going to be more convenient for me to actually multiply them out. So 4 times 3 is 12. A squared times a to the third. We're going to use our product of powers rule and say we keep the base and we add the exponent. Okay, and b to the third times b to the fourth is b to the 7th power. Okay, and so that would be the end of what we can do here. This is to the 5th. Right? We can't multiply anything else, and we can't, there's no like terms or anything to add. Okay, example number 2, we have 3 monomials, and 2 of the monomials, this first one right here, the last one right here, are being raised to a power. Okay, so the first thing we're going to do is we're going to get rid of those powers by distributing the exponent into all parts of this monomial. So this is, and be careful about this is negative 9 squared, and a squared and b squared. So you see how I'm writing parentheses around all of them. That is a very good thing to do. That keeps everything sort of organized. 2 times a to the fourth is, I can just drop those parentheses right away. And actually, you know, let's just keep those in parentheses for this step. So 2 times a to the fourth. And then the next one we have negative a, and I'm going to bring that exponent in there, and b to the third. So everything has its own parentheses. Now let's go get rid of the parentheses by actually bringing the exponent into those that have exponents. So negative 9 squared, that's negative 9 quantity squared. That's negative 9 times negative 9, which is positive 81. This is positive 81, a squared, b squared, 2, a to the fourth. Now negative a to the third power is negative a times negative a times negative a. So that's just, okay, that's positive a squared times negative a, and that's going to just be negative a to the third power. Okay, so that's times negative a to the third power and b to the third power. Okay, so let's just see what we have here. Let's put all the coefficients together. So I have, let's see, I have 81, I have 2, and that's my only coefficient, so we have 81 times 2 times, now let's think about the a terms, a squared times a to the 4th times, now negative a to the 3rd is the same as negative 1 times a to the 3rd. So what we can do is actually, let's put a negative 1 in here, and then let's put that with the coefficients on the second line. And then all I have to really consider right here is all that's left if I put negative 1 as a coefficient in front with the other coefficients is just a to the 3rd there. Okay, and then I have b to the 3rd. Okay, so let's see here. We have negative 1 times 81 times 2. 81 times 2 is 162, and times negative 1 is negative 162. A squared times a to the 4th times a to the 3rd, well, I can say that's a to the 2 plus 4 is 6 plus 3 is 9, times b to the, oh, and you know what, I'm missing a b squared from up here, aren't I? I never carried that down here, so I should have really put that there, which makes this b to the 5th. Okay, I'm getting a little rusty on these, so I made a few mistakes there, but hopefully you pick those out. If not, make a note of it, and we can go over this in class in the following day. Okay, example number 3, we have a negative 8 on the outside of a parenthesis, so the first thing that we have to do is we have to distribute this in. So by the way, this negative 8 is considered a monomial, and it's being multiplied by a polynomial. In particular, this polynomial is called a trinomial because it has 3 terms. Okay, so the first thing I'm going to do is I'm going to write negative 8 times 3x. Okay, that's our first term. Negative 8 times 3x. So let me draw my arrows as I'm distributing so that I don't forget. Negative 8 times 3x minus, so I'm bringing down that sign. And then I have negative 8 times 4x squared. Okay. And then I have the operation I'm going to bring down. And then I have negative 8 times 1/4 x. Okay, notice I brought down the operations before I wrote the negative 8 next to the following term. So let's go ahead and do all these out. Negative 8 times 3x is negative 24. Okay, minus. Now negative 8 times times 4x squared is negative 32x squared plus. Now let's see. Let's do 8 times 1/4 down here. So it's 8 over 1 times 1 over 4 would be 8 over 4, which is 2. But this is negative, so that makes it negative 2. Okay, so it's plus a negative 2x. Okay, now if we think about keep, change right here, we would, let's do KCC to clean this up a bit. We'd have negative 24 plus, and then that's changed right here, and this sign changes to a positive 32x squared plus negative 2x. Now, none of these are like terms, so the only thing that's left for us to do is to reorganize writing in descending power. So that's always the last step. We want to reorganize the expression into descending power. So starting with the largest power, or the power with the largest exponent. So 32x squared plus negative 2x, and that's going to be plus a negative 24. And our very last move is changing the combination of plus and negative back into subtraction because it involves less symbols. So we have 32x squared minus 2x minus 24. And that is our final answer there. And yes, you do need to change this back into subtraction because it's considered more simplified. This is considered more simplified than this one because it uses less symbols. Okay, and our final example here is this monomial right here being multiplied into this trinomial. Okay, so the first thing I'm going to do is I'm going to write negative 4 g squared h to the third next to each term. That's a third there. So distribute that in, plus negative 4g squared h to the third times 3g squared h minus I'm going to have to use the line below it to sort of do this. Okay, so I just write them next to each other. Now let's multiply them out. These two multiply together, but there's a coefficient on the second monomial, there's a coefficient of 1, so negative 4 times 1 is negative 4. There's not a g in the second monomial, so I'm just going to write g squared. And h to the third times h to the third is h to the 6th. Remember, it's not h to the 9th because it's not h to the third raised to the third power. That would be h to the 9th. H to the third times h to the third. This thing has h times h times h. This thing also has h times h times h, so that's h to the 6th power. Okay, so for the second one, let's see, we have that addition that will remain. So we have plus. Now, negative 4 times 3, we can think of those as being next to each other. So that would be negative 12. And then g squared times g squared is g to the 4th. H to the third times h to the first power is h to the 4th. Okay, we'll keep that subtraction there. That's bringing it down. So we'll keep this subtraction here. And then negative 4 times 1/4, those are the two coefficients, right? Negative 4 and 1/4. So that's negative 4 over 1 times 1 over 4. That's negative 4 over 4, and that's the same thing as negative 1. So that's going to be negative 1. Don't confuse the negative 1 with a subtraction. Okay, that's going to be negative 1. And then g squared times g squared is g to the 4th. H to the third times h to the first power is h to the 4th power. Okay, so let's do the final. Let's sort of clean up the final step, and this is interesting because these two terms are actually the same, right? They both have g to the 4th, h to the 4th, so we can actually add those together. Let's do a bit of keep, change here to clean it up. So I have negative 4g squared h to the 6th plus negative 12g to the 4th h to the 4th plus a positive, right? That's the change there, and this would be positive 1g to the 4th h to the 4th. And it turns out those are the like terms, so we can combine those, and that's actually going to be the first term because they have the highest exponents on those terms. So over here I have, I'll write my final answer in purple here. I have negative 11 g to the 4th h to the 4th. And then I can think of this as plus negative 4g squared h, g squared h squared. But remember, this combination of plus and negative, we're going to keep that as a subtraction. So over here we have negative 11 g to the 4th h to the 4th minus 4g squared h squared, and that is our final answer. Okay, there's a lot of work on this last problem, but this is the last example, and it's pretty important for you to be able to do all of this. Okay.